Hello, welcome to Zono Academy, and in this video we will discuss derived physical quantities. In the previous video we looked at one of the two types of physical quantities, that is the base physical quantities, and in this video we'll discuss the derived physical quantities. Now, by definition, derived physical quantities are just quantities that are derived from the three major fundamental quantities. So even from the word itself, these quantities are derived or gotten from the three major fundamental quantities. And amongst the quantities that we discussed in the previous video are mass, time, and length. So these are the three major fundamental quantities. So the quantities that are derived from these three are what are referred to derived physical quantities, or in other words, these are quantities that can be expressed in terms of other quantities. So this simply means the derived physical quantities can be expressed in terms of mass, can be expressed in terms of time, and can be expressed in terms of length. So they could either be expressed in terms of mass alone, or in terms of time alone, or in terms of length alone, or maybe a combination of all those. So these quantities that can be expressed in terms of these three fundamental quantities are what we refer to as the derived physical quantities. Examples of these derived physical quantities are examples such as velocity, examples such as distance, examples such as acceleration, examples such as force, volume, examples such as density, etc. So many other examples. All these examples can be expressed in form of can be expressed in terms of the mass, time, and length. So all these are what are referred to as derived physical quantities. So now I'm going to show you how we obtain these derived physical quantities from these three fundamental or basic quantities, which are mass, time, and length. So how do we derive these derived physical quantities? So I have put up a set of rules that can guide us in deriving these derived physical quantities. So number one is that derived physical quantities can be gotten directly from one of the three base quantities. So you could either have a derived quantity that is directly derived just from one amongst the three base quantities, or you could have a combination of just two out of the three basic quantities. Maybe you can just have a combination of mass and length, or you can just have a combination of time and length, or you can just have a combination of time and mass. So that could be also one way of deriving the derived physical quantities. And lastly, it can be a combination of all the three fundamental physical quantities. So you can have a derived quantity that is derived from all the three fundamental quantities. So you can have a quantity that is a combination of mass, a quantity that is a combination of time, a quantity that is a combination of length, all the three combined. All right, so let me show you how these three rules apply. So let's look at a few examples. So for example, we have the example of a derived physical quantity, distance. Now when you are measuring the distance, you are basically measuring the length. So distance, the symbol small letter d, is just a derived physical quantity that is derived from the length. So amongst the three fundamental physical quantities, which are mass, time, and length, distance is just a derivative or a derived physical quantity that is just derived from length. And another example of speed, we know that speed with the symbol small letter s is just a combination of distance and time. And when you are measuring the distance, you're basically measuring the length. So speed is just a derived physical quantity that is derived from length and time. So speed is a combination of length and time. So rule number 1 applies in deriving the derived physical unit distance, where we can see that this is just gotten from 1 amongst the 3, which is just length. And we can also see that speed is a combination of 2 amongst the 3, where we see length and time being combined in order to derive the derived physical quantity speed. And another example is acceleration, which is also just a combination of length and time. So you see that acceleration is just the speed over the time, and we know that the speed is a combination of length and time. So acceleration is also just a derived physical quantity, which is a combination of length and time. And then lastly, amongst our examples, is the force. So the force is now a combination of mass, length, and time. So we can see rule number 3 being applied on deriving this derived physical quantity force, where we combine mass, we combine length, and time all together to get this derived physical quantity force. So derived physical quantities could either be derived just directly from 1, or could be derived by a combination of 2, or basically a combination of all the 3. So this is how we derive the derived physical quantities. Now, the base units are the base quantities that we discussed in the previous videos. Their units are referred to as base units. So the units of these derived physical quantities are also referred to as derived units. So the base units are for base physical quantities, and the derived units are for the derived physical quantities. So this is how we get the derived units from the derived physical quantities. And an example is where we have the distance with the symbol d, and this is just gotten directly from length. And we know that length is measured in meters. So since length is measured in meters, then the units, the derived units of distance, would also just be meters. So in a case of speed, small letter s, and we know that speed is just a combination of length and time, and we know by formula that speed is just the distance over time. That just simply means that the units that will be derived from speed will just be meters per second. And also in the case of acceleration, symbol A, we know that this is a combination of length and time, but we know from the formula that this is just the speed divided by the square of the time. That just simply means that the derived units for this derived physical quantity will just be meters per second squared. Another example is maybe the volume, where you know that the volume with symbol V is just derived from length, but we know from the formula that volume is just given by length times length times length, meaning this is just length cubed. So this simply means meters cubed will be the units for the derived physical quantity volume. And this is how we get these derived units of these derived physical quantities. So this is all about derived physical quantities.